Lesson 2.4. Use postulates and diagrams. In geometry, rules that are accepted without proof are called postulates. Or axioms. Rules that are proved are called theorems. Unlike the converse of a definition, the converse of a postulate or theorem cannot be assumed as true. Let's look at some postulates for the point, line, and the plane. Postulate 5. Through any 2 points, there exists exactly one line. So if I draw any random 2 points, I could draw a line through the 2 points. Postulate 6. A line contains at least 2 points. So if I just draw a line, there are infinitely many points on the line, but you need at least 2 points to form a line. Postulate number 7. If 2 lines intersect, then their intersection is exactly 1 point. So one line intersects with another line, there exists 1 point. Postulate number 8. Through any 3 points, there exists exactly 1 plane. So if I draw any 3 points, then I could draw a plane. Postulate number 9, a plane contains at least 3 non-collinear points. So as you can see in this picture here, these 3 points are non-collinear. Postulate number 10, if 2 points lie in a plane, then the line containing them lies in the plane. So if I draw a plane, and then there's 2 points, and the line containing them also lies in the plane. Postulate 11, if 2 planes intersect, then their intersection is a line. So you draw a plane like this, and then the plane goes this way. And the intersection is a line. Example 1. State the postulate illustrated by the diagram. If we have 3 points, A, B, and C, then this plane here contains 3 non-collinear points, and that would be postulate 9. If you have 2 lines intersecting, then they will intersect at a point. That would be postulate 7. Okay, and this next one here, state the postulate illustrated by the diagram. This will have to be postulate number 11 because, excuse me about the picture here, you do have 2 planes intersecting in a line. Part B, which postulate allows you to say that the intersection of a line A and line B is a point? So that would have to be postulate number 7. Make sure you study your postulates, the basic postulates 5 through 11 well, as you will need to use them for further proofs. Example 3. Use the diagram to write examples of postulates 9 and 11. Postulate 9. Plane, let's choose Q here. Plane Q contains at least 3 non-collinear points. So we could have point W, point V, and point Y. postulate 11, the intersection of plane P and plane Q is line, so you have to read this line here, and it's named B. So line B. When you interpret a diagram, you can only assume information about size or measure if it is marked. So for the following picture, you can assume that all points shown here to the right are coplanar. You can also assume that point A, H, J, and D are, so A, H, J, and D are collinear. And if you look at angle AHB, you can assume that it is a linear pair with angle BHD. And for line AD and line BF, they intersect at point H. And for angle AHF, it is vertical to angle BHD. But you cannot assume that GF and E are collinear. And you also cannot assume that angle BHA, so BHA, is congruent to angle CJA. See, CJA. There's nothing indicating that they're congruent. And for line BF and line CE, you cannot assume that they intersect. And for line BF and line CE, you cannot assume that they do not intersect. And you also cannot assume that line AD is perpendicular to line BF, or that angle AHB is perpendicular. There's no symbol, there's no right angle symbol indicating that it's 90 degrees. It's not present. Example 4. Part A, sketch a diagram showing segment RS perpendicular to line TV, intersecting at point X. So you need to really pay attention to the symbols here. So we have the segment RS and the line TV, intersecting at point X, and it needs to be perpendicular. So we need to draw the symbol, the right angle symbol. Now for part B, sketch a diagram showing that line TV is intersecting segment PQ at point W. Okay, let's first do that. So we have line TV, segment PQ. No, this drawing is not perfect. Intersecting at point W, and then we want to show that segment TW is congruent to segment TW is congruent to WV, so this one. So we need to use the little marks. So one little mark indicating that they're congruent. And here we have a line is a perpendicular to a plane. It's a biconditional statement here. If and only if the line intersects the plane in the point and is perpendicular to every line in the plane that intersects it at that point. So we have a picture right here that illustrates this statement, biconditional statement. Now let's quickly do example 5 here. Which of the following statements cannot be assumed from the diagram? Look at A. E, D, and C are collinear. E, D, and C. We can assume that because they lie on the same line. And let's look at part B. Line EC is perpendicular to plane G. We cannot assume that because there's no symbol. And if we look at part C, line BD, is that perpendicular to line EC? I would say no, because we don't have that right angle symbol. So no right angle symbols. You could just write that for B and C. And the intersection of line BD and line EC is at point D, so that's correct. And we will continue the lesson in class.